the lateral surface area of a prism, of a right prism specifically. Well, if you look at the vocabulary here, lateral means side, and so we're talking about the area of the lateral faces. So there's one in this particular diagram. There's 1, 2, 3, 4, 5 lateral faces. We're talking about the area of those 5 faces. Notice that this does not include the area of the top or the bottom of this particular prism. In other words, the area of the 2 bases. We would not consider that part of the lateral surface area. The lateral surface area would be in general found by perimeter times the height. So what I mean by the perimeter is, well, the perimeter of the base. So this distance going along here. This is a 5-sided figure. If I was to start here and work my way around, that would be the perimeter of the base. Now the reason this works is, imagine, we're talking about these 5 sides of this particular figure. If I was to cut along here, and let's pretend the top and the bottom are not part of this. If I was to cut along here and unfold this, I would roll it out, and each of the 5 lateral faces would end up being individual rectangles. And if I was to roll them out, I'd end up just getting one big rectangle. And it turns out this distance right here is exactly our perimeter. This distance right here is the height of the prism, and so the area of this big rectangle is the perimeter times the height. And you'll notice that's exactly what the lateral surface area is here. When we're talking about these diagrams, h is, we can interchangeably say height or altitude. They kind of mean the same thing. It's how high it is there. P is going to be the perimeter of the base, like I said, and A is the area of the base. So if we're talking about the total surface area, then what we do is we take the L, which I just defined right here as the lateral surface area. We take that lateral surface area and add it to the top base, and the area of the top base, and the area of the bottom base. Those are each equal, so when I add those together, I get 2 times A. The other formula we need to know for a right prism is the volume of the right prism. So the surface area is how much space is on the outside. It's the area of all these faces. So this would be L, and my total surface area, which we're calling S here, would end up being all of this stuff plus the two pentagons, the one on the top and the bottom. That would give us our, these are the 2 bases, and so the total surface area would end up being that. That's why we end up getting this formula. The volume is measuring something different. The volume is actually measuring how much space is on the inside of this prism. You can look at that at a couple of different ways. You can say, okay, how much room would this take up if you were putting it in something, or and the other way of looking at it is how much water can it hold. If this was a tank, and I was to start filling it up, filling it up here, how many gallons of water could that hold? That would be describing the volume of this thing. Now, we're not going to be describing volume in gallons very often. We're generally going to be using cubic units because they're just easier to work with. But we can find the total volume of this just by taking the area times the height.